Hello everyone, and welcome to our tutorial on using quadratic equations for calculating optimum sales. Today we will learn to predict the optimum sales using quadratic equations. We will use Power Query and Python to calculate the coefficients of quadratic equation, and then we will use those in equations to calculate profit on various sales volumes to find out the most optimum sales volume. We will also demonstrate this model using Power BI visuals and dashboards. We have this historical sales and profits data in a spreadsheet, which we are going to use to optimize our profits. We are going to use a quadratic equation to identify the optimum level of sales at which the profits are highest. Quadratic equations are widely used in business and economics, particularly in optimization problems, finding the maximum profit, maximum revenue, or minimum cost. This is achieved by analyzing the equation's graph, the parabola, and its vertex. So let's import our historical sales data into Power BI Desktop. Let's select the sales table and click on the Load button to load the data into the Power BI Desktop application. And here is our data in the data pane. First, let's create a dashboard to display historical sales and understand the relationship between sales and profit. Let's add a title to our dashboard. Now add a gauge chart to display the average, minimum, and maximum sales during the period. Add the sales field to value as average. Then add the same to minimum as minimum and to the maximum as maximum. Now place the chart nicely on the top left of the dashboard and turn on visual borders. Copy this gauge chart and replace the sales field with profit field to display average, minimum, and maximum profit as well. Now add a line and column chart to display monthly sales and profit values. Sales are number of units sold. Add date field to the x-axis and remove year, quarter, and day from hierarchy. Add sales to column y-axis. Add the profit field to the line y-axis. Turn on visual borders. All these charts point to a strong correlation between units sold and profit earned. However, to further understand the correlation, let's add a scatter chart. Add sales to x-axis. And remove aggregation by selecting Don't Summarize. Similarly, add the profit field to y-axis, again without aggregation. And now you can clearly see the strong positive correlation between units sold and profit earned. So far, the data shows that there is huge potential in sales, and we can easily expand business and earn more profit. However, there is a concern that high sales may not always result in high profits, so we need to perform further analysis and identify optimum sales instead of blindly expand sales. For that, we need to go to the Power Query, so let's open our data set in Power Query now. And now, we are in Power Query. Let's duplicate the sales table. add a Python script and import pandas and NumPy libraries, which we are going to use in our Python code. Previously, we showed you this equation, which we are going to use to evaluate the optimized sales. We will use Python script to calculate the values of A, B, and C for this equation. Define a variable x to store the values of sales from dataset. And a variable y to store the values of profit from the same dataset. Now let's calculate the coefficients from x and y values. We will use the NumPy library and the polyfit function to get the values of A, B, and C. 2 represents the degree of polynomial, and since quadratic equation is a second-degree algebraic equation, 2 means quadratic equation. Let's assign the results of polyfit to A, B, and C variables. And now we can finally store the values of A, B, and C in a data frame to load them into our Power Query table and eventually into our data pane. We will create a data frame using Pandas library. First, we will define a column to display titles of our values. Now, we will create another column to store the actual values from variables A, B, and C. Click OK, and if asked, ignore the privacy warning. Now you have 2 datasets, the original one and the data frame containing the values of A, B, and C coefficients. Click on the table to display the data frame values. And these are the values of A, B, and C coefficients of our quadratic equation, which we will use to calculate the optimum sales. Now, select both columns, and in the Transform tab, click on Pivot to pivot this table. And now rename this table to something meaningful. We can now use these values to calculate the optimum sales. To predict optimum sales, we need some data, so let's add some data into a table. We need 1 column for serial numbers. Let's add values from 1 to 20. In the second column, we will add sales units against which we want to predict profits. You can choose any values. There is no rule as to why we are entering 20 values and why we are entering these specific values. Save this table as model. Now, add a new custom column from Add Column tab. Call this by the same name as your coefficient table. Now select your coefficient table here as well. Click on the OK button. Now select the columns from coefficient table using the 2 arrows button on top of the custom column. Now we have quadratic equation coefficients in our model. And this way, as soon as more sales data is entered into the sales table, coefficients will be recalculated and updated here automatically, always providing latest optimum sales value. Finally, we can click on the Close and Apply button to update data into the data pane. Now we have the model table in Power BI, which we can use to predict optimum sales value. So let's go to the table view and add a new column to our model table. In this column, we will calculate profits using quadratic equations shown on screen. And now we have the values of profit calculated using quadratic equation, and we can already tell which sales value is the optimum with highest profit. Let's create another dashboard and add a title to that dashboard. To identify optimum sales with highest profits, we will add a line and column chart. Add the profit field to the column y-axis aggregated as sum. Add the sales field to the line y-axis, again aggregated as sum. And finally, add the n field to the x-axis. And there you go. Now you can easily tell at which sales units we can get the highest profits. And this also confirms that profits will start decreasing after a certain sales volume. To further demonstrate our model, we can use another line chart. Add the profit field to the y-axis. Add serial numbers to x-axis. Let's turn on visual borders for this visual. We can also add a slicer here to demonstrate our model on a single sales value. Go to Slicer Settings and select Less Than or Equal to from Style. Now our charts will change based on slicer. However, axes of our line chart are changing, which we don't want to. So we will manually set the minimum and maximum axis for x-axis of our line chart. Now x-axis are fixed, but our chart is still not stable. To keep the y-axis fixed, we will manually set their minimum and maximum as well. Now it looks perfect. No matter what value we select, the size of chart area remains same. Now, create a copy of this visual and temporarily place it anywhere on the dashboard. You can see that both charts behave in the same way, however we want to change that. Let's go to the filters of duplicate line chart and add a top n filter in serial number field. Enter 1 in the text box, and in the by value insert same serial number field, aggregated as sum. Now instead of line, we have a dot, because now based on slicer, only one value will be shown on this chart. And now it's time to turn off any interaction between slicer and the original line chart. And then remove background from the duplicated line chart so that the original chart is visible behind. And finally place the duplicated line chart exactly over the original one. Now both charts are working as a single chart, and it seems that there is a dot moving over the line. This way we can see values of entire model and a profit against specific sales as well. We can also add horizontal and vertical lines connecting the dot to x and y axis. Now we can demonstrate model more clearly. You may also want to display the data labels to exactly display the value of profit when slicer is used. We have displayed serial number on y-axis, but it is way better if sales are shown on y-axis instead. So now we are going to replace the serial number field with the sales field in both charts. We need to reset minimum and maximum for x-axis as well, because values have now changed. Instead of 20 and maximum, we need to set the value of maximum to at least 38. We need to do this in both charts. And now our model demonstrates perfectly. We can see that the optimal sales volume is either 18 or 20, where profit is the highest. Any sales more than this volume will likely result in lower profits. This fact cannot be determined from the other dashboard, which only shows increase in profit as the sales volume increases. And with this, we end our tutorial. We hope this tutorial was very helpful for you in understanding Power BI, data visualization, as well as using quadratic equations for optimization. Have a nice day. See you soon with another interesting tutorial.